Hi guys, it's Eniola again. Welcome to the second video of this series, Competitive Data Science. I have with me here my co-host.
Hi guys, this is Said here.
So in this video, we're going to be introducing Victor Olufemi. Victor Olufemi is popularly known as Professor on the Zindi leaderboard, and we are going to be sharing with you insight on how we achieve top place on the leaderboard on competitive data science.
Okay, so guys, in competitions I participate in Zindi.Africa a lot, there's a particular name that is always top leaderboards, and that's Victor Olufemi. His name on leaderboards is Professor, right? So I'm really excited about this one because I'll get to hear from the man himself, hear tips, hear a lot from him. So I'm pumped and excited for this video.
So I introduce to you Victor Olufemi. Victor Olufemi is popularly known as Professor on Competitions website. Victor currently works as a data scientist with FarmZ2U, and Victor is currently ranked at the moment as the 10th out of 60,000 data scientists on the Zindi platform, which makes him the current highest ranking undergraduate.
Okay, so looking at Victor's competitions highlight, yeah, he has, for him to be the top 10 participant on Zid, he must have won a lot, but we are just going to scroll through some of the top three that we can highlight here. Yeah, so Umoja Africa 2020 took second place. Yeah, it took second place. Other competitions he has participated in are the Kenya Sign Language classification, where he also took first place. Wow. Also, the Swahili Audio Classification Hackathon by Zindi Weekend, it took second place. And even from the looks, from the competitions, you can see like there is a variety of competitions. And for him to have high ranking in these competitions, which means he has something to offer us in this video.
So we have Victor in the house already, Victor Olufemi. First of all, I would like to say congratulations on all the hackathons you have won. Basically, we are going to be pushing for the recent one you have won, which is the Umoja Africa 2023 and the Britgit Challenge. So Victor Olufemi participated in this competition titled NFT Prize Prediction Challenge, and he came first in the leaderboard. This is the leaderboard. Just keep okay. Yeah, this is Victor Olufemi. He came first in this competition, and he also participated in this Umoja Africa 2023 challenge, while his team emerged second in the leaderboard. So Victor, congratulations once again, and I would like to start like this. Can you just introduce yourself and share us about your journey in the field of data science? Over to you, Victor.
Thank you so much, in your yeah, the wonderful intro. So basically, yeah, my name is Olufemi Victor, and currently I'm an ambassador at Zindi, and also a data scientist. I started my journey as far back as 2019, where I joined the DSN. Then was called Data Science Nigeria. They have a community club in my school, my university where I attended, Obafemi Awolowo University, and they had this small like a subgroup of DSN in school, and that's where I first got to learn about data science, AI, and what it entails. And following that experience, I was privileged to participate in the boot camp. They had a boot camp that was held in 2019 as well. And from there, on and on, I began to grow myself within the data science space, and found myself competing as well on Zindi.
So we actually have the beginner, intermediate, and advanced, and we noticed that you decided to participate in the intermediate competition, which is the Cryptojacking detection challenge. So our question is for you is this: what inspired you to actually participate in that competition out of other competitions?
Okay, so funny enough, I was in a team, yeah, so called Team Solo. Myself, Paul, and Dunson, and we actually participated in the three challenges. That's both the beginner challenge, the intermediate, as well as the advanced. just to lay hands on the problem and try to exploit. But particularly the intermediate challenge was quite interesting because of the nature of the problem was pretty straightforward, and it looked like something we could win without too much boggling. Yeah, so that was some of the reasons why we particularly put more focus on the intermediate challenge.
Okay, so nice answer there. Yeah. So detecting illegal cryptocurrency mining from like website activity is not really like a popular challenge like you see around. So like, can you just walk us through like the approach and strategy you employ to tackle this challenge effectively?
Okay, yeah. So thank you so much for the question, Said. Right. So as you said, cryptojacking is something that is unique. In fact, I myself, this was my first time, working on something around this space. So essentially, our approach was pretty simple and straightforward. I would also, do well to drop you the link to the notebook, which is available on GitHub. But essentially, what we did was to create, some certain features, right? Because the features that we're given were features that, talked about the CPU usage, right, of the machine, or, whatever was being measured, right? And we had, data points, the time on the processor, the amount of, bytes sent over the network, the amount of pages that were being read, etc., etc. Right. So we had to create new features from some of the given features. And what we did essentially was we tried to group all the activities that were ongoing. So let's say you have features around the hard disk, right? So we have a central feature that combines all the hard disk based features that were given. And we also had several features that were dealing with network, right? Network packet sent, network packet received, and the likes, right? So we had a feature as well again, that combined all the network activities. And so also we did for the CPU usage as well. So those were some of the things that we did. And yeah, also quite interestingly, it was a classification challenge, right? And so we also had to check for data imbalance and the likes, right? So scaling the data to make sure we have this kind of balanced data points back, right? So for our what's it called, modeling, right? So we decided to scale the POS weight to account for that data imbalance. So those were some of the things I would say we did that got us out of the professional score.
Yeah. Thank you. Yeah, it's actually nice that in your previous answer you mentioned some of the features that you used. You mentioned about network and about CPU. Yeah. So like, if the features used in the competition, what are the things that you do that when you see a feature, you know that, oh, this is what we use, that this feature is useful to the model. Like, can you shed light on like the feature selection methods you used to know, oh, this feature will be useful or this one will not be useful? Yeah.
Okay, so yeah, I thank you for your question once again, Sai. Right, so conventionally, what I do is when I join a competition and start modeling, I try to build a baseline model, and I try to do that as as fast as possible, and as let me say as least complex as possible, right? That is, it should be very simple, right? So when I build this model, I try to plot the feature importance, right? To understand what the model thinks, or what features the model thinks is most important. And those are some of the things I pay attention to. So before I plot the feature importance, I also check for I do a correlation plot, right, to see what features actually most correlated with the target, right? So those two plots are the plots that have guided me so far, and that's what I do every time I join a competition. Just try to understand what features are most important, and how can we squeeze out the best from those features. Yeah, so that's how I perform my own feature selection, and how I'm guided through the whole modeling
Yeah,
process.
okay, yeah. So given that, this competition particularly is a unique competition. So like, is there any special, like, we know what modeling is generally, fit your model on the data set. Like, is there any special innovative technique or method you applied like during the modeling process of this competition?
Yes. I would mention that, during the competition, or while we're modeling and the likes, on the public leaderboard, we're actually 14th place, right? And when the private leaderboard came out, we landed in the second place, right? And that was a very big boost, a big move for us, because you notice that the score range between the second place downwards, you find that they were very close, right? And being able to say, this is the model, that well, most likely seem to perform the best, right? It's something that is very tricky there. So aside just building a model, because we built a model, used Optuna to tune parameters and to get the best result, right? But after doing all that, we were able to also visualize the count, right? So after modeling and building the model, we actually try to understand what's the distribution of our of the predicted targets now. So we compare the train and the test, and that's what we've just predicted now. And through that, we're able to say, oh, this is what we most likely want to choose as the winning solution, or the solution we would submit. So it was more than just saying let's build a model, but it was rather more about understanding the outputs that came out from those models.
Yeah, thank you very much, Victor, for the answers. So I would like to ask a question about the modeling approach. So for me, if I participate in machine learning competition, I prefer to stick to a model, so I have time to actually delve into other parts like the data and maybe checking for the feature importance and all that thing. So the modeling approach I like to stick to, if it's a classical machine learning problem, is usually cat boost, and sometimes I just try LG boost. So my question for you is, what algorithm do you utilize in all this kind of competition, especially the cryptojacking detection challenge? What algorithm did you focus on?
Okay, so for the cryptojacking, right? So specifically was the light GBM, and of course that's always a go-to model because of speed. I mean, it's really fast, right? And it's of course lightweight, as the name implies, right? So that was the algorithm that we used, and also we did a stratified cross validation. Right. So because I mentioned that the target itself was imbalanced, right? So we had to stratify the way the data was split, so that we can have that that balance there. So specifically, yes, it was the light GBM, and we tried a couple of other models, just to see what the score was going to be like. But overall, light GBM seemed to be the best, and of course that's what we started with. So we just kept going with that, and try to get the best out of light GBM, rather than trying to find several models here and there, and especially because there was a time constraint there. You have to finish up within was it 48 hours or so, right? So
yeah, beautiful work. Exactly. Another question comes from the time framing. So how do you undo when like you have less time to participate in an hackathon? How do you undo yourself during those kind of competition?
Yes. So for me particularly, I always like really love hackathons where the time is limited, right? Because it means at that moment it's more about who can think faster, right? Because you don't have much time to say you want to go back to relax for the whole day, and come back after several weeks, right? So it's like you are given a challenge on the spot. And it's up to you to now come up with ideas, come up with strategies within that time frame, right? So essentially, it's something I enjoy personally, right? And when I'm opportune to do such bounded time hackathons like that is something I personally love to jump on.
Thank you very much. So we are going to be looking at assembling techniques. Did you undo your modeling with any assembly techniques?
So I mentioned that we used just
Like
one just one classifier that's light GBM, although we used a cross validation, so that's building several light GBM models, right? And specifically we did a stratified k-fold of 10 splits, so that's like 10 different light GBM models, right? Then we just used a simple averaging, right, of those models to then get the output. But specifically was the modal score, because I mentioned it was a classification challenge, right? So we had to take the mode of all the output of those models, right, to get the final output.
Looking at the leaderboard, actually, we can see one guy having like a very perfect score. What do you think is?
Yeah.
What do you think is it?
Yeah.
I did.
In fact, I was really impressed, and for several weeks after the challenge ended, I kept going back there to check the discussion if if the team would actually release the solution, so I can learn from them and see what they actually did. But although I can't say for sure that I understand what exactly they did, but of course they must have have really put in some strategies in place, which I believe is most likely post-processing. That's after coming out with the outputs, possibly some extra post-processing was done on the targets. But if you look at from my team score, that was 97. You'd see that everyone is within the range of 97, 97. You don't even have a 98, talk less of a 99. But then you have a 1.0 again. So yeah, that was really impressive.
Okay, yeah. So like when you participate in a particular competition, like there are some lessons you learn. For example, even in this discussion, I've learned the importance of like viewing the value count of your target. So like from these competitions, what are some like notable lessons that you've learned that you intend on applying to like your future data science endeavors?
Okay, so in terms of lessons learned, right? I would say one of them is especially when you are doing competitions like this, because I mean, competitions most time is you want to get the best result, right? That's the goal essentially, the best result. So I would say some of the key takeaways I personally have taken from this competition, and several others, particularly is trying to be patient enough to actually get the best hyperparameters, right? Because most times, folks, everyone at the end of the day, we're all using, the same model. Is that you're using, CAD Boost, Light GBM, XG Boost, most likely Random Forest as well. Or maybe you're doing an ensemble of some of those four, right? And sometimes it all boils back down to, who is able to get the best out of, the available models, which are not so many, right? So I usually take my time out to actually, say, oh, let's find, the best hyperparameters. Let's tune this model efficiently. And of course, let's also get the best we can get from it. And aside also, taking the time out to find hyperparameters, I think also, strategizing on, finding innovative ways to create more features and new features is also, something that is very relevant. So I would say over time, those are some of the two things I think, anywhere I go, I love to take them, and I love to, reapply them to future competitions.
Was there like any particular course or like resource or learning material that you found especially useful when preparing for this competition?
Okay, so for this, I would say no, not really. But of course, I was able to, do my my own personal, search. I mean my Google search, and trying to learn, what those features actually mean, right? And I'm also a big fan of learning from others, right? So when I see, when a competition ends, I take my time to actually study the winning solutions, what they've done, and see how I can apply them to probably future competitions. And sometimes there are even some competitions that end, and I save the winning notebook, particularly so that when a competition comes up next, I can then apply these strategies to the competition, right? So sometimes maybe there's for instance, a segmentation based competition that I've not done before, and I find a good notebook. I try to save that notebook, and when I have a competition, I try to implement what was done before. So for me, it's much more about learning from others, learning from the community, and of course there's no end to learning. So that's how I learn personally, and find my own resources.
Hi guys, it's Eniola again. Welcome to the second video of this series, Competitive Data Science. I have with me here my co-host.
Hi guys, this is Said here.
So in this video, we're going to be introducing Victor Olufemi. Victor Olufemi is popularly known as Professor on the Zindi leaderboard, and we are going to be sharing with you insight on how we achieve top place on the leaderboard on competitive data science.
Okay, so guys, in competitions I participate in Zindi.Africa a lot, there's a particular name that is always top leaderboards, and that's Victor Olufemi. His name on leaderboards is Professor, right? So I'm really excited about this one because I'll get to hear from the man himself, hear tips, hear a lot from sense. So I'm pumped and excited for this video.
Okay guys, stay tuned with us. We'll catch you.
You'd have to grow gradually in the space, and funny enough, if you actually go probably to the community, that's the Zindi community tab, and check out the profiles of the top 10, you'd find out that there were times whereby they were also taking average scores in competitions. There were times back then when they also started when they were at the bottom of leaderboards, and over time you'll find out as time went on, they began to grow in the space. So also I would just put out that advice to newbies that take your time out to actually grow in the space, learn from others, learn from winning solutions, try to collaborate with others as well, so that you can learn. And yeah, you keep learning by doing, right? So write more codes.
Yeah, I agree with you. When I started out also, the whole motive was I need to win. But as time goes on, you discover that you actually need to learn to be able to win.
Exactly.
And with the more knowledge you gain, winning will come easily, actually. Yeah. So, Victor, thank you very much for the interview. So the last one before we go is how, if you were to go back in time, actually, to start from scratch, how will you do things better as a data scientist?
So yeah, so I get you. I get you. Thank you so much for that question. So if I were to go back in time, personally, I would say I'll do more of collaborations, right? And of course, something I particularly am proud of myself for is releasing a lot of solutions for people to learn, right? So I would like to do more of that, more collaborations, more releasing of solutions, so that folks can learn. And I myself also would try to grow myself, learning from pros and other grandmasters. Yeah, so those are some of the things that I particularly would want to have done more.
So guys, this is Professor. We are going to be sharing with you the details to the GitHub link where you can see the solution to the code and also learn from it. Also, you can check out the social media handles on LinkedIn, Twitter. You are not really active on Twitter, but I know LinkedIn for sure. You can check him out on LinkedIn. Still the same name, Victor Olufemi, and is popularly known as Professor. Thank you very much, Victor.
Yeah, thanks. Thanks, Victor. Thanks.